Hello, my name is Josh Gregory. This is the video walkthrough for the prototype 2 of Pizza Management System. So this is the ERD, the outline of the tables that I plan to use for the database. There's a customer table, a payment table, an order table, and then an associative entity ordered item that relates to menu item table, and with two subtype tables, beverage and pizza. And if we click over here, this is the class UML. It's basically a one-for-one conversion from the database schema. There's a customer class, order class, ordered item class, payment class. One difference being that the item class, I incorporated the beverage and pizza subtypes, the fields for those, into a single item class, just for simplicity. And then over here, there's a payment gateway class that would create objects that use a payment gateway API, which is required for online card transactions. And then also the receipt printer class that uses .NET's system.drawing to allow a user to create print document objects, and then it can interface with external hardware and send the print document to the printer. And then in the middle here is database operations class. That would be used to with data.sql client .NET namespace, and it would allow users to create a object that could connect to a database server, that could take strings and create a SQL query from those strings, and then actually query the database and read back the results. And that's why it's connected to the major classes here, because there are fields in each of these major classes that need to be stored in the database. That would be the production version of the app. But with the prototype version, it's just implementing the menu, which is item class, and then it's also implementing order requirements, which is based on the order class. And then there's limited functionality in the GUI to reflect payment class and ordered item class, but I don't actually implement those as classes in the prototype. So this is the source code, and if I scroll all the way down here to where class definitions begin, which I included them all in the same file. So right here, there's a pizza class and a beverage class. So rather than doing an item parent class, I just defined the pizza and beverage subclasses, just because really the only fields that they share is size and price. And then the order class. So the way it works is every time a pizza object or beverage object is created, it's added to a pizza list or beverage list, and those are initialized in the constructor. And then the pizza list and beverage list, right before submitting the order, those are iterated through, and that's what allows the objects to be displayed on the order cart or view order screen. So the order ID here, that would relate to the primary key for the database table. I use a helper method here, generate order ID. That's right down here. All it does is increment a static integer that is it's incremented each time an order object is created, and then that's added to a timestamp. So you have this incremented counter and the timestamp that serves as a unique ID that could also be used as a primary key. And then I have various methods for calculating totals, for adding a beverage, adding a pizza, and removing either one. Because the challenge is to keep the item display and the order totals display, to keep those dynamic to where they change along with the state of the order changing. So if I go to the actual app and double click to launch, it's gonna pull up the app that functions as a standalone app that doesn't require .NET runtime being installed on the local machine. Everything is included inside the folder. And the displays here are made using a tab control. And with the tab control, you can add multiple tab pages to the form. So rather than going through and making a form for each screen or using user controls, tab control just has tabs that look like browser tabs, and you just can add as many as you need. And then they're usually visible, but I resized the window to make them hidden. So the help button here has the credentials for the login screen. And then after this screen, the help buttons just have placeholder text. So we're going to type in, and we'll forget the 1 at the end of the password. So it checks the text boxes to make sure that they match the hard-coded strings. And since it didn't, it wouldn't validate. So now I'll enter in the right password. So for this screen, transaction history, that's from prototype 1. It's disabled for for prototype 2, since this just focuses on the menu ordering and order cart functionality. So we start a carryout order, and it takes us to item select screen. So if this was the full production version, one of the fields that would need to be added to these objects when they were created would be item type. And if item type equaled P, then it would go into the pizza subtype table. And if item type equaled B, it would go into the beverage subtype table. So at this point, we can log out. If I hit yes, it would take me back to the login screen. It also canceled to home. Did that, it would take me back to the this screen right here. So what happens is at the top of the source code, an order object is instantiated, which initializes those two lists and also the order ID. And that's done at the top of the form class in order to facilitate data sharing between tab pages throughout the system. Otherwise, you can run into issues with passing data between tab page elements. So we'll start a delivery order instead and add a pizza. And if I tried to add without selecting these required combo boxes, I get a warning for that. And that just is a simple if-else check. if combo box equals null. So we'll do a small, and the base price for a small is $6.99, and then extra cheese is $1.99. And then the special instructions for the prototype, I limited to 30 characters using a helper method that truncates any strings over 30 characters passed in as an argument. So we'll do more than 30 characters just to test that it is truncating. Okay. So we'll go ahead and add this without any toppings. Okay, so the base price was $6.99 and it's showing as $8.98. That's that reflects the extra cheese being added. So it shows the size, the crust, the sauce, the extra cheese selection, and then in the display method for pizza, if the toppings list has a count of 0, then it displays plain cheese instead. And then special instructions, as you can see, it did truncate at 30 characters. And over here, every time an object is added to either a pizza list or beverage list, a calculate order totals method is called that dynamically updates this list box. And then this is dynamically updated using get beverage details and get pizza details, which sort of function like a two-string method. So I chose checklist box here. That way there is a built-in ability for users to select an item, and this is based on a 0 index. So whereas the first item is the 0th index, the next item would be the first index. So when if I click remove here, what it's going to do is go through and check each index that has an item added to it. So each index that has a value, it's going to check to see if the checklist or if the checkbox was selected, and if so, it's going to delete that. And then it also updates the order totals, which is $3.99 because it's a delivery order. So if we go back, we can add a beverage. So when I click add here, it's going to validate that the size and quantity fields have been, it's going to validate that they are not equal to null. So I add that, and if I try to add a lemonade without doing anything, it's going to give me a warning. So right now, the root beer is added to a temporary list, and the reason for that is because a user might want 2 different sizes of the same flavor. So I'll add a couple different ones. And then once I click add beverages to order, at that point it's going to go through the temporary list and add all the beverage objects in that list to order.beverage list. And then as soon as that button, it also calls the update item details method and calculate order totals method. So say the customer wanted to go back and change their order type to carry out instead, and then go to view current order, and now the fee has been removed. And then we'll add a pizza with 5 toppings on it to show how that works. So the base price for small again is $6.99. I'll just do 5 toppings here. So I chose to do whole, left half, and right half, just to give the customer more options. So these 4 toppings will be added at no charge, but once you surpass 4 toppings, every topping greater than 4 is going to incur a 99-cent charge. As you can see, it's $6.99 base price plus the charge for the extra topping. All right, so at this point, if the user or if the customer was happy with their order, the user can go in and get their payment method and select that. They try to submit before selecting. Of course, that will be validated and give a warning. So if they're paying with a card, it submits, and what I did was added a method to format a receipt using message box here, just to sort of simulate what a receipt would look like. So the order ID again is that was created through the generate order ID method when the order object was instantiated, and then it goes through and calls get pizza details on each pizza object in the order.pizza list, and displays that as a string. And then it does the same with beverages. It goes through the order.beverage list and calls get beverage details to display that here, just the same as it does in the checklist box. And then this would be order.order type field, order.order total field, and order.pay method field. And storing them as fields for an object like that would also make it easier to get that data in order to update or create a database record. And then for the payment for card payment method, I added a signature line here, and then it has an estimated pickup time. I just did a random value between like 15 minutes and 45 minutes, I think, and then that random value is added onto a datetime.now object just to create an estimated pickup time. If that was a delivery order, it would be probably a little longer. And then after that, it goes back, so the user can start over. So if we did a new carryout order for the next customer, I'll just add something real quick here. So we see we're on our 3rd order here. And then after all the customers are served, the user can log out. And that's it. Thank you.